Chapter 9, Test Review. You are going to need your ruler and a pen so that I can tell which shapes are which. And hopefully you will remember our different little tricks with reflections and rotations as far as coordinates are concerned. Let's look at number 1. What are the coordinates of the image Q reflected about the origin? Now, if you remember, if something is reflected about the origin, what happens to x, y is that the points become negative. So you can graph it and double check it, but if you remember our little trick here, you do not have to graph it. So the new points of Q, or Q prime, are going to be positive 3, 6. Okay? Number 2, go ahead and plot those points. P, Q, and R. And it says to reflect it in the x-axis. This right here is your x-axis. So P is now going to flip down to here. So our rule says that your x, y, when you reflect it about x, the y changes. So the x stays the same, but the y changes. So P was 3, 4 becomes 3, negative 4. Q, which was 5, negative 1, becomes 5, positive 1. And R, which was negative 3, 0, well, that's going to stay the same because 0 is not positive or negative. But I do need to graph the image, so I'm going to plot these points right here, the reflection, in green. I'm going to go to 3, negative 4, and I'm going to go to 5, positive 1, and excuse me, and let's connect those, and you could see our triangle flipped directions. Number 3, how many lines of symmetry? So we're talking about line symmetry. So this is a rhombus, so yes, it will have corner to corner and this corner to corner. So 2 lines. Number 4, you can see that it's reflected down and then down again. So since it's reflected twice, it is as if it just translated or moved down. So we can say yes, it is reflected in both A and B. It has to be reflected in both for it to be a translation. Okay, number 5. Find the image of UT. Again, you can graph this on graph paper and then know that this vector means you're going to go over 2 in the X and then go down 5 in the Y. And that's fine. You can do it on graph paper, or you can remember that what that means is your negative 3 on your X is going to go over positive 2, and the 5 on the Y is going to go down 5. So our new U point is going to be at negative 1, 0. And V, same thing, 0 plus 2 and 8 minus 5. Our new V point is at 2, 3. And you can check it with a graph if you'd like. Number 6, we're going to rotate it 90 degrees. So when you rotate, our rule says that they are going to change positions and become negative. So point C, 4 is going to come first and be negative, and 0 is going to be last. Our new D, 4 and 3 are going to switch, and they're both negative. Again, you can check that on your graph. Number 7, you're going to rotate it about the origin and then reflect it in the y-axis. So two things happening. So if I rotate it, what happens to my points? Yeah, they switch places and y becomes negative. And then what happens? Yes, and then when I reflect it, the x changes. Alright, I'm only looking at point Q. So Q starts out at 4, 2. Oops, that's not Q, that's O. Q starts out at 1, negative 2. And when I rotate it, Q becomes 1, 2, 1. And then I'm going to reflect it. And Q double prime, or the second thing, it's going to be negative 2, 1. Okay, there's where it ends up. Again, check it with graphing. Number 8, order and magnitude. Remember, order means how many times you have to rotate it, and magnitude means how many degrees. So the order pentagon has 5 sides. The order is 5, and the magnitude is 360 divided by 5, which is 72 degrees. Number 9, we are going to rotate this 90 degrees. So what happens when they rotate? They switch and y becomes negative. So let's take point A, negative 1, 3, and it becomes negative 3 because they switch and y becomes negative, negative 1. Let's look at B. Point B is negative 4, negative 4. They switch and y becomes negative. So Nubia is at 4, 4. And C, negative 2, 1. Switch directions, negative 1, negative 2. These rules are really important to remember. You can always graph it to double check, but you could also memorize them. Okay, so here's my original image, 3, and here is my dilation, 8. So what I want to know is 3 greater than or less than 8? It's less than, so it got larger, so we call that an enlargement. Number 11. Find the measure of GH. GH equals 7. Scale factor of 5. So if GH is 7 now and it's 5 times larger, the new GH will be 35 units. Because 5 times 7 is 35. Okay, number 12. Number 12, we're going to dilate it under scale factor of 1/3. So you need your little ruler. I'm going to use a protractor. Here's the center of dilation, G. So if I measure GD, I'm going to see that GD is about 1/2 inch long. So my new GD is going to be 1/3 that size. So 1/2 times 1/3 is 1/6 of an inch. So about right here. Okay, let's do GE. You measure GE, it's also about 1/2 inch. So same thing. It's also going to be 1/6 of an inch. So about right there. Okay, let's do our last side, GC. GC is about 3/4 of an inch. Let's multiply that, and that will be 1/4 of an inch. That one's pretty easy to measure. Okay, now I'm going to use my pen and I'm going to draw my new shape. And you can see it's about 1/3 of the size. Okay? Number 13, find the scale factor. Now to find the scale factor, first I want to know, is this an enlargement or a reduction? Well, it went from 15 to 20, so it got bigger. So my scale factor should be bigger than 1. If it's not, then I need to flip my numbers. So my scale factor is going to be 20 over 15. 20 is larger. And I'm going to reduce that to be 4/3. I'm going to leave it like that. Number 14. Let's see, what happened here? Did I reflect it? No. Did I translate it? Nope. It looks like I rotated it. It is a rotation. Number 15, draw a translation in the figure along -3, 1. So each point is going to go -3 units, or left 3 units, and then up 1 unit. So 1, 2, 3, up 1. 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 That's what your new figure is going to look like. Okay, 16. How many lines of symmetry can you draw in an isosceles trapezoid? So an isosceles trapezoid looks like this. Those two sides are the same. So you can draw one line. Excellent. All right, last page. Here we go. A figure M is reflected in 2 pair of lines that are 3 inches apart. So let's draw a little figure. Here's my figure. And it's reflected in 2 parallel lines. And these 2 lines are 3 inches apart. And here is my new figure. So if from here to here is 3 inches and here to here is 3 inches, how far did it go down if I just wanted to do a single transformation? Well, it went down vertically, so vertical translation down, gotta say what direction, 6 inches. Okay, number 18. Again, you can draw this out on graph paper, or you can use what we know about vectors. Negative 11, now it's going negative 2 units, so 2 units left, minus 2. And then negative 7, and it's going 3 units up, so plus 3. That becomes negative 13, negative 4. It's my new point. Number 19. Same thing, we're going to translate this along a translation vector. Okay, so A right now is 3, 0. Translate it along 1, negative 2, and it becomes 4, negative 2. B, which was 6, negative 5. Add 1 to x, minus 2 from y, becomes 7, negative 7. C was 0, negative 3. Translate that, and it becomes 1, negative 5. And D was the point negative 1, negative 2. And it becomes 0, negative 4. So those are my new points for my polygon. Number 20. I want to know the largest scale factor. So if I picture, here's my poster right now. It's 3 feet by 2 feet. And I have my wall. And my wall is 14 feet by 8 feet. I want to know what's the largest scale factor. So I'm going to compare my scale factors here, height, and my scale factors here with the width, because they probably are not the same, but I want to know what is the largest I can use without my poster hanging off part of the wall. So if I compare these two, 14 over 3, I get 4 2/3. Okay, that means this side of the wall is 4 2/3 larger than this side of my poster. If I compare the heights, 8 over 2, I get 4. So this is only 4 times larger. Since this bottom is longer scale factor wise, if I use this scale factor, then my poster won't fit on my wall. Part of it will hang off up top. So this is my largest scale factor, is 4. Yes, some of my wall may be showing, but at least I won't have part of my poster that will have to be cut off. Okay, the bonus, I'm going to let you try it. You have a reflection and a translation. So all I'm going to tell you is think, how can you get from 1, 5 to 5, negative 2? You have to reflect first. So a reflection and something, and then it's followed by a translation. So translation along some sort of vector. You need to graph your points first, and then think about it. When I check your review on Wednesday, if you have this bonus correct, I will give you some extra credit.